Okay, so now I want us to look at the asymptote, right? So what I need you to note is to understand what is an asymptote of the graph and which graph have the asymptote. So there's only two types of graphs that have the asymptote, which is the hyperbola graph and also the exponential graph. So first things first, you need to understand what is an asymptote, okay? So when I say determine the asymptote of the graph, I'll definitely show you what you need to do. So the asymptote is the line which the graph will come closer and closer to, but it never crosses or never intersect or touch that graph. This will make sense. Now let's start with hyperbola. Right. So if you still remember the hyperbola, if this is the first time you hear the word hyperbola, the hyperbola, it's an equation that will be in the form of something like 1 over x, let's say, plus 2. So when I say 1 over x plus 2, I'll show you how this graph looks like, okay? So this graph, it will look like this, right? So this is my x axis and this is my y. From there, we're gonna have the value of a as positive. Please, uh, if you don't understand what's going on here, please make sure that you stay on the lesson because this is just introduction. I don't want to go into too much details, but we'll do this when we do the examples. I'm only interested in explaining what is an asymptote. So now, when I look at this graph, since I have that plus 2, this tells me that my horizontal asymptote will be somewhere at this point. The horizontal asymptote is the line that cuts the y-axis. And the vertical asymptote, since it's only x on the denominator, it will be on that line. So what I'm trying to say is that we're going to have our x, which is the one that cuts the x-axis. It cuts the x-axis at 0. And this one is the one that cuts the y. It cuts the y-axis at what? At 2. So since the value of a is positive, I'm going to have my graph in first quadrant and the other graph in second quadrant. So the other graph, it will be like this. Remember, it must not touch the asymptote. So when I look at this, I can see that this is my asymptote and this is my horizontal asymptote. Your graph must not touch that red lines because we say that an asymptote, this asymptote is a line, right? It's a line. Okay. So it will be, let me just fix this. So it's a line, an asymptote, it's a line which a graph. So the graph come closer to. So the graph will come closer and closer, right? But remember, the graph must not closer and closer to, but it must not, it never touches that graph, that line. It never touches, right? Or cross the asymptote. The asymptote. I hope you guys understand the asymptote. Right. So an asymptote is a line which comes closer and closer to, but never touch or cross the asymptote. So the graph will come closer to that line, but it must not touch the line. So this one is for the hyperbola. We can also work on the one that has to do with, most of the time you'll work with exponential equation. So the exponential equation, you'll have something like y is equal to a number to the power variable and then plus 1. So if we draw that graph, the graph will look like this. Right. So now this is an exponential function. It only have one asymptote. So the asymptote of your graph, you're gonna see it with this +1. So if it's +1, therefore it should be somewhere there at 1. So this one, it only cuts what? It only cuts the y-intercept. You'll never have the asymptote that cuts there, the asymptotes that cuts the x, unless if we are talking about the inverse function, which is something that you'll do in the upcoming grades. Okay, so this is why it's equals to 1. So now we'll definitely work on how the shape of the graph looks, but now I'm just going to draw my graph and show you how this works. Remember, this is my graph. We can say this is the graph of y. It's equal to 2 to the x plus 1. So the graph must not touch what? The graph must not touch that asymptote. So now I think you understand what is an asymptote. The graph must not touch this part. So that's what we call an asymptote. So the asymptote here, it's y is equal to 1. And this side, the asymptote is y is equal to 2 and x is equal to 0. So to conclude this, for hyperbola, we'll have two asymptotes, the vertical and the horizontal. So this is the horizontal asymptote. And in this lesson, we're going to call it HA. H for horizontal, A for asymptote. And this will be the vertical asymptote in this lesson. We're going to call it VA. V for vertical, A for asymptote. Now that you understand what is the asymptote, the next thing that we're going to discuss is what we call the domain. You need to understand what is the domain of the graph and how do we find the domain of the graph. Okay, so when you hear in an exam, they ask you that determine, they need you to determine the domain of a certain graph. I'll explain how to find the domain. So this will be easy marks. The domain, this domain is something that we refer to. When they say the domain, they are asking you for which values, for which x values does the graph exist. Does the graph exist? We're going to work on multiple examples so that you can understand what is the domain. Does what? The graph exist. Okay, so what I'm going to do on this one, if I'm just going to give you, let's just do simple. Let's say I have a Cartesian plane like this, and remember this is my y, and then we have this one which is the x. So the domain, we only focus on the x values. They'll be asking you about the x values. So let's say that I have an equation like this. Remember, this is a parabola. So this is a quadratic equation. So I'm definitely going to explain what is the domain. So let's say that you are flying along the x-axis and you will look at the left and right. Okay, so let's say you are flying. This is you. I'm just going to try to put you on the x-axis. So this will be you, and you are definitely flying in. You are flying from what? Let's say you are flying from left to right. You are moving in that direction. Okay, so now in order for you to understand the domain, please listen to this. You need to listen to this. So when you fly, when you come to this point, right, when you come to this point, you see this arrow. This arrow tells you that the graph still continues going up. So when you are on this point, you ask yourself, you look left and right. So this tells me that, let's say, this side of the x-axis, it's my left, and this side will be my right. Okay, so when you are flying in that direction, you are flying in that direction, okay, and you look left and right. So now you need to ask yourself which values of x you will see on the graph. Which values of x do you see? You can see that when you are at this point, you definitely see that x value there on the graph. Remember, we're talking about the graph. When you are on this point, you definitely see the x value. Remember, each and every point on the x, each and every point, there's what? There's x values. Each and every point, there's x values. When you move, you ask yourself, you see, when you are at this point, which x values do you see there? When you are at this point, which values do you see? Which x values do you see? When you are at this point, which x values do you see? You see, this is what you need to ask yourself. So look at this. When you are moving from left, when you are flying on the x-axis and you look left and right, you can see that you see all the x values that are on the graph, all of them. You see all of them. The more you continue going that direction, you will see all the x values. So this tells you that, in other words, the graph exists for what? For all the x values. So the domain of this parabola, the domain will be x must be an element of real numbers. I hope you understand that. Né? So x must be an element of real numbers. So the other notation that we can use is to say that x must be an element of, we see all the numbers from negative infinity all the way to positive infinity. So this is the domain. This is the domain, and that's how you identify the domain. Okay, so on this, I need to let us work on something here now. The domain of now I was trying to make you understand what is the domain. Okay, so the domain, you fly on the x-axis and you check which x values can you see on the graph. What about the range? What about the range? So the range, this one, they are asking you that for which values, y values, does the graph exist? You know what you need to do here. Né? So for which values does the graph exist? This is what they are asking you. So you're going to fly on the y-axis. This is you'll fly on the y-axis. You'll move in that direction and you'll definitely look left and right. You look left and right. But now look at this. Let's try and let me give you something. You see this point here? I'm just going to draw a line like this. Okay? So, look at this point. This is you moving from on the y-axis. You are flying. But look at this. Can you see that this point, when you get on this point, you don't see any x values on the graph. You don't see any x values. But the moment you start passing through this point, let me indicate this. The moment you start passing through this point, this is where you're gonna start seeing the x value, the y values on the graph. This is where you're gonna start seeing the y values on the graph. You see, this is where you start seeing the y values on the graph. So this tells you that the range will start from that point going up. So it depends on what y value you are given. Let's assume that this is -3. So the range of this graph, it will take from -3 going up. So the range is that y must be greater or equal to -3 because it takes from -3 and we start going up. So if this is not making any sense now, please make sure that you wait for an example where we will be working on different graphs. But for now, the range will be y is greater than or equal to -3. So The other notation that you can use, you can say y must be an element of, you write the small number first, which is -3, and it goes all up to positive infinity. So it starts at -3 and it's move all the way to what? All the way to positive infinity. Right, that is the range. And now that you understand the range, let's go through each and every type of equation that we're going to work on. The first one that I want us to discuss is the straight line. Okay, let's work on, because now that you are in grade 10, most time you'll be working on a linear function, which is what we call the straight equation. So this is the straight line. Right. So let's talk about the straight line. So first thing first, you need to understand the standard form of the equation of a straight line. Okay. So the equation, it is in the form of y is equals to mx plus c. This is the first one that you can use. And we call this the straight line form. And then we have another one. So if you don't want to use that one, we can use the formula that goes by y minus y1 is equals to m into x minus x1. So let me explain what is going on here. I'm just going to first start with this one. So in an exam, when they say put the equation of the graph in a standard form, this is what they are referring to. So this is the standard form. The standard form. So what I'm trying to say is that even if you choose to use this equation here, even if you choose to use that equation, whatever that you get, it will be in that form. You need to make sure that you simplify and put it in standard form. I hope you understand that, partner. So let's explain what is y1 and what is x1. So look at this. I have what we call y1 and xy. I'm just going to explain this part because we need to subtract y1, we need to subtract x1. So the point x1 is to y1. This is what? This is a point on the line. So it's any point on that equation, that straight line that we have. So it's a point on the line. This will be a point on the line. Okay, so we're just gonna work on some of the examples. Let's go through these things to make sure that you understand what we are doing here now. So, and then now this is the first thing that you need to understand. Then second thing, it's m. You see that m there. So m, it's your gradient. So the m is your gradient. Right. So you need to understand how to calculate the gradient, and we're gonna use the formula that says the gradient is equals to y2 minus y1, everything divided by x2 minus x1. Okay, so what I need you to note in this one is that you see this point here. This is a notice, okay? Please notice that the y is always on top. It's always on top. Right, the y is always on top. So now, this graph is the same as saying that we can, this is the same as saying, when you look at this is the same as saying, this is what? The gradient is equals to the change in y over the change in x, because we are subtracting what? We are subtracting y2 minus y1. Okay, so this is the change in y. The top part is the change in y, and we're definitely subtracting what? The change in x. That's how it is. Né? So to find the gradient, there's nothing you can do, but you need to have 2 points. So to find the gradient, to calculate, in order for you to calculate m, you need 2 points. Okay, you need to have 2 points to calculate the graph, 2 points to find the gradient. Okay, so now that you understand how the equation of a straight line looks like, let's talk about the y-intercept. You need to understand how to calculate the y-intercept of the graph. Okay, so on the y-intercept, to find this, we're gonna let x to be equal to 0, meaning that on the equation where there's x, you substitute 0, and then and you solve. You're gonna solve for y. Okay, so what I'm trying to do, if I have, let's say, the equation of a straight line, which is y is equal to 2x plus 3, and we need to find the y-intercept. What will be the y-intercept equals to? So to find the y-intercept, I'll say that the y-intercept, if x is equal to 0, meaning that where there's x, we need to put 0. So y will be equal to 2 into 0 plus 3. So if you punch that on the calculator, you'll find that the y is just 3. So the y-intercept is 3, but now this is the y coordinate. Remember, we already have x to be 0. The coordinate of the y-intercept is 0 and 3. I hope you understand that part. This is how you find the y-intercept of the graph. Nice. So you can use the same to find the x-intercept. Okay, remember the x-intercept. So to find the x-intercept, we need to let y to be equal to 0, meaning that if I have the equation y is equal to 3x plus 2, where there's y, we need to substitute 0. So this will be 0. This is 3x plus 2. So you let y to be 0, and then what happened next? And you solve for x. Right. So when I have it, remember we are still talking about the straight line. So when it's like this, I'm going to bring the 2 to this side, and it becomes -2. It's equals to 3x. So isolate x by dividing both sides by that 3. Therefore, what is x equals to? -3 over 2. So the coordinate of the y-intercept, of the x-intercept. So the coordinates of the x-intercept will be -3 over 2, and the y is 0. Okay, so now we're just gonna work on, let's talk about the domain, the range, the axis of symmetry, and the asymptotes. Okay, we are still on the straight line equation. Okay, so now on the straight line, remember it is in the form of y is equals to mx plus c, close the bracket. So if we look at this, you need to understand how to find the domain and the range. So if there are no restrictions, just know that the range, remember the domain is which x values does the graph exist. It exists for all real numbers. Okay, so this will always be the domain, nothing changes. Also the range, it will always be y is equals to y must be an element of real numbers. Okay, so now the most important thing that I need you to understand is that the domain will always be that. The range will always be that. Okay, unless if you are given a restriction, we'll definitely talk about that. Okay, but most cases in IEB, That's when you can get restrictions. But in caps, there are no restrictions, okay? So the axis of symmetry, okay, remember the axis of symmetry, it's a line that divides the graph into two equal parts. So the axis of symmetry, for this one, the axis of symmetry, it's not applicable. Né? So what I'm trying to say, a straight line does not have the axis of symmetry. And then the asymptote of a straight line. Then this one, same, none. The straight line does not have the asymptote. I hope you guys are having so much fun. Remember, we are still discussing the straight line. Okay, so now let's go back. Let's go back to the domain. Let's go back and talk about not the domain, but the gradient of a straight line, because it's very important that we fix this while we still have time, okay? So if you still remember the gradient, we said if I have an equation like this, y is equals to mx plus c. What is the gradient? M. So the gradient is m. So let's talk about this m, the gradient. So let's say that m is positive, okay? Let's say that m is positive. So if m is positive, therefore this tells you that your gradient is greater than 0. Okay, so the gradient is greater than 0, and an example that I can give you is that the equation will look like this: y is equals to 2x plus 1. Look at the 2. The 2 is positive. So the 2 is positive, and how will the graph look like? I'm just going to do a rough sketch, okay? I'm just going to do a rough sketch. So your graph will look like this. So now, one thing that you need to understand when it comes to the gradient is that I'm just going to take you and put you on that graph, okay? So this is you. You are working well on the graph. This is you. Can you see that? You are moving up, okay? So this, if you walk on the graph from, let's say you walk from left to right. Let's say you walk from left to right, okay? We can see that you going uphill. You are you walk uphill. You walk uphill. You are going upward. So we can conclude and say the graph is what? The graph is ascending. The graph is ascending. Right. So when we say ascending, we are saying that this is an increasing graph. Okay? This is an increasing graph. So it's very important that you also understand that. So if it's an increasing, if the graph is increasing, if the straight line increases, what can we say about the relationship between the x and the y value? So this tells you that as the x increases, the y also increases. So the y increases also. That is the relationship. Right. So let's talk about if the gradient, let's say if the gradient is negative. Okay. So if the gradient is negative, therefore we can conclude and say your gradient is less than 0. And I'm just going to give you an example of how the equation will look like. It will be something like y equals to negative 2x plus 1. Look at the gradient, it's negative. Here the gradient, it was positive. So if this is how it looks, let's check on how will the graph look like. This will be my graph. I have this as the x, this as the y. So your graph will look like this. Remember, you're still walking from left to right. Né? You are walking from left to right. So I'm just going to put you somewhere up here. And this is you. So now you see that when you walk from left to right, what is going on? This time you are walking what? Remember, left to right. So when you walk from left to right, you are going down here. Okay, so this tells you that the graph is descending. Therefore, the graph is descending. Okay, the graph is descending. So if the graph is descending, it's what we call a decreasing graph. So the graph is decreasing. So to conclude this, we can see that as the x increases, look at the x values. So for a decreasing graph, if the x increases, the y decreases. You just have to look at what is going on the graph. As you can see, let's start with this point here. If this is minus 5, which is the x, and let's say the y is 10 there. You can see that at this point I have x as minus 5, but at this point I have x as 5 and then the y as negative 2. You can see that the x increased from minus 5 to positive 5. So the more you walk down, the x values are increasing from minus 5 to 5. So at this point here, you'll have the x of what? 5. And then the y of minus 2. So the y was 10, then it end up being minus 2. The more you walk down, the y are decreasing and the x are increasing. That's right. So this is when the graph is positive, when the gradient is positive, and we also discussed when the gradient is negative. So now one thing that I need you to understand when it comes to this graph, because it's very important to know the shape of the graph. How will your graph look like? They might ask you to draw the graph, okay? So now, let's say that the gradient this time it's equals to 0. So if the gradient is equal to 0, you'll have an equation like maybe y is equals to 2. So the graph will look like this. Now, it's what we call, it will be the horizontal line. Okay, so if it's y is equal to 2 and this is your 2, your graph will look like this. So this is the graph of y is equal to 2. So the line runs horizontally, okay, and then it cuts the x-axis only. So we can conclude and say that if the gradient is 0, it cuts what? The y-axis only. Okay, it will cut the y-axis only. So we're gonna have the equation that is parallel. The equation that is parallel to what? The equation that is parallel to the x-axis. So what I'm trying to say in this example is that this line is parallel to that x-axis because this is your x, this is your y. Right. So let's say that your gradient is undefined. Okay. So if your gradient is undefined, so if m is undefined, I'm not sure if you understand the weight undefined. So we'll definitely talk about that. So if m is undefined, you're gonna have an equation like this: x is equal to 3. So if m is 0, y is equal to 2. But if m is undefined, you'll have your equation as x is equal to 3. Okay, so now how will your graph look like? So the graph will look like this. Okay, this is my x, this is my y, and we know that it cuts there at what? At 3, and this will be my equation. Right, so this is x is equals to 3. So the gradient is undefined, the graph will, the line will run what? Will runs vertically. So it's gonna cut the what? The x axis only. The x axis only. Okay. So now look at this time. Look at this one now. The line of the graph will be parallel to what? To the x, to the y-axis. I hope you understand that part. Né? I hope you understand that part. We are still working on the equations. We are still explaining the straight line. So we are almost there. Then on the next lesson, we'll definitely talk about the parabola. Everything that you need to know about the parabola. So now, when you have straight lines, there are some of the things that you need to pay attention on. The first one, you need to check if how are the lines looking like. Sometimes you might have two lines, or they might say that the equations are parallel. So if we have parallel, and we're gonna use these two lines to denote parallel. So if you have parallel lines, right? Let's talk about the parallel lines. So if I have an equation like this is my x axis, and this is my y axis. So now, if I have two lines like this that are parallel, okay, let me redraw that. Let's say we have two lines that are parallel like this. So I'm just going to call the first line y is equals to 2x plus 3, and this one is y is equals to 2x minus 3. Maybe this will be minus 3. So now look at these two equations. What I need you to pause the lesson and try to understand, what do you see on these two equations? Do you see anything that is common on these two equations? So I need you to compare the equation 1 with equation 2. What is common? The 2x. So if you still remember the standard form of a straight line, it's mx plus c. So m is the gradient. So you can see that these two lines, they have equal gradients. So f at the line, let's call this f, and let's call this g. So the line f is parallel, okay, is parallel to what? To g. Therefore, we can conclude and say that, okay, or we can use f parallel to g. What can we conclude about that? Is that the gradient are the same. So they will have the same gradient. So the gradient of the first equation is equal to the gradient of the second one. So both of these gradients are equal to 2. So when you have it lines that are parallel, just know that they will have equal gradient. So let's say you are in an exam and the statement says that the graph of f is parallel to the graph of g. Just know that they have equal gradient. Okay? So if you understand that, I'm very happy. This tells me that we are moving, and we need to move with the movers. Okay? So now, I'm just going to talk about the perpendicular lines. Let's say that we have lines that are perpendicular. Right. The lines that are perpendicular, remember the perpendicular, it's represented by that. Right. Okay, so if I have lines that are perpendicular, I'll have the, okay, let me draw my Cartesian planes first. Let's say this is my Cartesian plane, like this, okay? And I have a line like this, and this line, let's say it's y is equal to 2x plus 1. And let's say maybe we have another line moving like this. Let me say this is my X, this is my Y. Okay, so now I'm just gonna put maybe a line there, and the equation of this line is y is equal to minus 1 over 2 x minus 2. So this line, it is given that these two lines are perpendicular, so they form a 90 degrees there. Eh? So we can see that the equation, let's call this f and let's call this g. So we can see that our f, okay, it's the equation of f is perpendicular. It's perpendicular to what? To g. Okay, so since they are perpendicular, we can conclude that look at this. This is 2. The gradient this side is minus 1 over 2. So when you, if two lines are perpendicular and you multiply their gradient, if we take the gradient of f, we multiply that with the gradient of g, we need to get an answer of minus 1. So what I'm saying here is that the product of the two gradients is equal to minus 1 if the equations or the graphs are perpendicular. So let's try and test that theory. So the gradient of f, remember this is in the form of y, it's equals to mx plus c. So this is in that form. We can say my gradient for f is 2. Multiply that by the gradient of what? The gradient of g, which is minus 1 over 2. And what is this equals to when you put it on the calculator? You can just punch that on the calculator. You'll find this is minus 1. So now the gradient of f multiplied by the gradient of that g, we get minus 1. That's what you need to understand. So if lines are perpendicular, they'll have the product of their gradient to be minus 1. And if lines are parallel, they will have the gradients that are equal. So you'll see how to use these things to solve problems. So please make sure that you note this down and you understand the theory behind the perpendicular lines, the gradient theory behind the perpendicular lines. Okay, right. So now in most cases, you'll have to work with what we call collinear points, because on a straight line, you might have 3 points, and we call those points collinear. Okay, I'm going to explain what is collinear points. So now, collinear points, this one, we're going to say that if I have a straight line like this, this is point A, this is point B, and this is point C. So A, B, C, A, point B, and C. These are collinear. Okay, they are collinear. I'm going to explain what is collinear. So these are collinear. So now, ladies and gents, collinear, this means that we can draw what? We can draw a straight line through these 3 points. So when we say points are collinear, this tells you that we can draw a straight line through these points. So that's why we call them collinear. Okay, so now if points are collinear, just note that the gradient from A to B, the gradient from A to B, the gradient from A to B, it will be equals to the gradient from B to C. So the gradient from A to B, this is the gradient from A to B. This is the gradient. We can find the gradient from B to C. We can also find the gradient from what? The gradient from A to C. All these gradients should be equal. If you have collinear points, just know that the gradients will be equal. That's one you need to understand when you work with collinear points. So in an exam, if they say A, B, C are collinear points and the gradient of A, B, it's 5. Find the gradient of AC and determine the equation of AC. Already you know that the gradient of AC will also be 5, okay? So everything will make sense when we do examples, because now on this lesson, we're just focusing on what you need to know to master straight line equations. Okay, so now the last thing that we're gonna discuss on this one, the last thing that we're gonna work on this one is drawing a straight line. There are 4 types of equations, okay? There are 4 types of equations, so that's what I need us to work on. Drawing the straight line equation. This is the last part of the lesson. Okay, drawing a straight line. Okay, so on drawing a straight line, we have what we call 4 types. Okay, we have 4 types of equations, okay? 4 types of equations. I'm going to first start with the first one. Right, so remember that the first one, it should be in the form of mx plus c, right? And we said that this is what we call the standard form. The standard form. So how do you draw the equation? Or it can be any equation that has x and y. So first thing first, the step number 1, you need to first find the y-intercept. So let's say you need to find the y-intercept. And how do we find the y-intercept? You let x to be equal to 0. Step number 2, you need to find the x-intercept. Then you need to let what? You need to let y to be equal to 0. So we are drawing the equation, so they'll definitely give you the graph, say y is equal to 3x minus 1. You need to know the y-intercept and the x-intercept. Therefore, you are done. You can just connect these 2 points. Okay? You can connect these 2 points. That was easy, enough. Right, that is the type 1. Type 2, let me give you the type 2. The type 2, this was the first one. The type 2, remember we are discussing 4 types of equations. So it will be in the form of y is equal to mx. So you can see that this one, we don't have the y-intercept. Okay, this one does not have the y-intercept. So you just have to find what? C, the value of C. This value of C is the y-intercept. Okay, it's where it cancels the y. So you need to find what? You need to find the y-intercept. So you just have to find the y-intercept, and then okay, the y-intercept, we already know that it's 0. So I'm just going to say the y-intercept, not find, but the y-intercept is equal to 0 because it's in the form of mx plus 0. So you can see that the y-intercept, the value of c, is 0. So this, if there's no value of c there, we say it's 0. Then you're going to plot 1 more point on the graph. So you'll see when we work on examples. So ladies and gents, that's it for straight line equations. I'm looking forward to working on examples with you. Okay, so this is what you need to know when it comes to the equation of a straight line. And if you really enjoyed the lesson, I'm looking forward to see you on our next lesson. So on our next lesson, we'll be working on examples on how to solve problems that has to do with sketching the straight lines, finding the equations of the straight lines, and so on. So thank you for sitting in on the lesson. And if this is your first time watching the lesson, our lesson, please make sure that you join the family by subscribing on the channel, and we'll make sure that you feel at home. Please trust me, You don't want to miss the next lesson. Sharp, sharp.